All right there, Algebra 1. We're going to work on scatter plots today. I get a little warm up for you to work on there, just to review slope-intercept form, because we're going to continue using that as we work on some things. We're going to use some technology today and not as much doing this by hand. So make sure you try that one out and see how you do with it. Like I said, we're going to focus on scatter plots. It's a type of graph that you've probably done before, and you're going to put, plots and points all over the place until you see kind of something going on, or you might see nothing at all, right? So scatter plot is the main idea, and we're going to use these to compare points of data and determine the relationship between them. So we're trying to find out if there is a relationship, even if that relationship is no relationship at all. Right? If we can find a pattern on it, we call that a trend line. Okay, so usually we have the word trend line. We can identify a correlation, and it may have been called a line of best fit. Okay, so those are all the different things that we can say, and they all mean basically the same thing, right? Line of best fit is what we put on because we see a trend, and that trend tells us what type of correlation we have. So there's a couple ways to label those, and here's what we have so far. A positive correlation, okay, so that might mean that I have all these points, and look, from left to right, they're going up. And the other thing that I added here is they're all really close together. They're basically all in a line, right? Okay, so I would call this strong. Strong. So when I do this as a week, I'm going to keep these points nice and close together and have that on there as well. So a negative correlation, and we're going to keep those strong as well, nice and lined up. No correlation, that's kind of what you see up here in the box. So we'll just put some points all over the place. It's not really going up or down. It kind of looks like the chicken box, right? You don't want any of that. All right, now I can have a negative correlation that I see that there's a downward trend to it. There's definitely something negative about it, but it's kind of all spread out. So these we could identify as weak versus strong. Right? And that's one thing we start to introduce in Algebra 1, but we don't really test for it until Algebra 2. But I want to make sure I put that in front of you. So if I ask for a correlation, right, negative, positive, or no correlation, those are the answers we're looking for. If you feel comfortable identifying that it's pretty close together, we'd call it strong on top of that. And then weak, if you're like, yeah, it definitely is going up, but they're kind of spread out. So we'll call it a weak correlation, weak positive correlation. So that's just some of the vocabulary without doing anything with it. All right, the next thing we're gonna do one of these by hand. So sorry, this part's gonna take a little bit longer. Kobe has been exercising and losing weight each week. So good for Kobe, right? Maybe it's a New Year's thing. I don't know. And we're going to create a scatter plot. So hours of exercise. So that's going to go along the x-axis. So this is going to be my hours, and it looks like we have to go from 1.3 to 5. Okay, so I might call this 1. All right, that's 3. 1, 2, 3, 2, 3, 4. All right, now why did I pick to go 3? I just want to spread it out. It makes it a little bit easier to deal with. Okay, so that'd be 0 back here. Okay, so that's my hours. Now the other part of it was weight loss. Okay, and they had pounds. All right, and it looks like that goes from 0 to 3.5. Okay, so let's just call this what, 1, 2, 3, 4. All right. Again, not really necessary that I use all the space up here as long as I'm consistent on the scale. And that just had some markers on there that I felt would be pretty good for that. Okay, so hours of exercise 1.3. So I'm going to go 1.3, and Kobe's going to lose half a pound on that workout. Then he goes for 3 hours, and he's going to lose almost 3 pounds, right? 2.8. And then we're going to jump up to 5 hours, and we'll get 3.5. And then it only worked out for 2 hours, and he lost 2.5 pounds in that workout. And then it worked out for 4 hours, and he lost 3. Right on the money. All right, so it seemed like the 1.3 and losing half a pound, like that was way off of everything else. So as I look for a trend line, I'm probably not overly worried about that. If I wanted to make sure that I had it kind of split, I would definitely split those out if I'm looking for that. Now, overall, the only thing we're really looking for is what type of correlation did you find between the hours of exercise and the weight? Okay, hopefully at this point you feel comfortable saying that you found a positive. And outside of the first one, I would say this was pretty strong. But again, that's not necessary at this point. But I just want to make sure we point out some of those vocabulary for in the future as we continue to use scatter plots. All right. Now I'm going to focus a lot today on just interpreting and seeing what's going on. So that was kind of our one thing. If you can plot points, then you can make a scatter plot. That's not a big deal. So I want to make sure you can understand how to read them. Describe which of the following statements best describes a scatter plot. Shows how one part of the data compares to the whole. Okay, so does it compare to the whole? Scatter plot shows how quantity changes over time. Is it always about time? That's the other question. Scatter plot shows the number of times each item occurs. That seems like frequency, right? We're not keeping a table, so I'm going to get rid of that one. Scatter plot shows how each part of the data compares to each other part. All right, now I don't recall every scatter plot I've ever done dealing with time, so I'm going to get rid of this one. And how it's part to whole. It was really dealing with the hours and the amount of weight. It wasn't about the whole weight, so I'm going to get rid of that one as well. Okay, so you can see how these are going to be a little bit tougher. And obviously, I did take my time and try and point out some things to show you why those other ones are wrong. All right. So just thinking in general, if my height increases, right? As my height increases, what normally will happen to my weight, right? I'm also going to find that that's also going to go up. Could it be a little bit strange, right? Are there people that weigh more that are shorter or people that weigh more that are taller? Right? There's always going to be some of those outliers, but overall, in general, from the time you were a baby until you grew up now, your weight has increased because your height has increased. So we're going to find that if they're both increasing, then I'm going to have a positive correlation. All right, what about the value of a car and the age of the car, right? So when I bought a new car, well, my wife bought it, right? And then over time, what happens is the value of this car just keeps going down. Now, so the value of the car, right? So the value is going to decrease. So let me get rid of that arrow right there. So the value is going to decrease while the age increases. So notice I have a negative and I have a positive. So this is going to cause a negative correlation between those two things. Now, if you're into cars, you know that sometimes eventually the value is going to go back up because it got so old. There just aren't as many of them. You get the idea. Now, my IQ score versus my shoe size. Now, I wear a men's shoe, but these are just going to be all over the place, right? There's some people that are super duper smart and they get really small feet. There's some people that are super duper smart and they get really big feet. And there's some people that don't score as well in the IQ scores. Okay, so there is no correlation going on here at all. If you compare your shoe size and your IQ, it's going to have nothing to do with each other. All right, so let me go back here just for a second. Now that we pointed that out, and part of what we had to do here was make a scatter plot. But notice what's going on. If I kind of look at these, all right, 1.3, 2, 3, 4, 5, they're out of order. But notice what happens here. We get 0.5, 2.5, 2.8, 3, and 3.5. So if I were to line these up, I would find out that these are increasing and my weight loss is also going to increase, which means I expect to have a positive correlation. So the only reason I really need to see the graph is to identify if it would be strong or weak. And I'll show you how to use Google Sheets here in a minute, so you can find that information as well. All right, so let's look at some generic ideas here. So we're going to sell some lemonade and it's compared to the temperature. So the temperature outside is something that we cannot control. So we're going to say as the temperature increases, what do we think about the number of lemonades? So let's put the number of lemonades over here. So if it gets hotter and hotter out, what do you think is going to happen to my sales? That's also going to increase, right? So if I have a positive over a positive, then I should get a positive because we're talking about the slope, right? So this should happen. So it's a positive. All right. Determine whether scatter plot the data for your age and the color of your hair might show a positive, negative. All right. So the color of your hair and your age really have nothing to do with each other. Now, I've had this argument with students before, like, well, when you get old, you might get gray. I'm like, well, you know what? I'm not getting gray. I just don't have much hair at all. So it is what it is. You know what I mean? So we're going to say that there's actually no relationship. I don't know what's going on here. A, B, B. All right. So we're going to take the second B, which should be a C. I don't know what's happening there. Like I said, today's going to be a lot more conceptual. Okay. So if you're watching this at home and you need a little break before we get into this set here, we're going to talk about the weights and the heights of babies. Okay. This is a nice sequence of questions that deals with this graph right here. Okay, so we'll get an idea. So the height is increasing here. The weight is also increasing. It seems like they're very parallel to each other, but we'll get into that as we take a look at it. What is represented by the point labeled A? Okay. All right, so whenever I see this, I always like to do a quick highlight and connect these two values so I don't get things mixed up. So before I look at my choices, I need a height of 24 and a weight of 11. Height of 24 and a weight of 11. A baby 11 inches long. Okay, so that's automatically wrong. A baby 22 inches long. No, because I'm looking for 24, right? A baby 24 inches long. Okay, so I got a winner so far. Weighs 12 pounds. Okay, that's not what I was after. I was after 11. 24 inches long, weighing 11 pounds. All right, here it is. All right, so it was J. So we got to be careful that both of those numbers match up in what we're doing. So a pretty easy way to deal with that in interpreting what happens. All right, now we're going to work off the chart just a little bit if I remember correctly. The height of Sandra's baby is 19. I don't know why I say it all the time. Sandra's baby is 19 inches. Okay, based on the data on the graph, what would you expect the weight of her baby? So we're looking for inches. 19 would be right back here. So if this were to continue back, I kind of split the middle because I don't really know what to put it on. All right, so would we expect the baby to be 4 pounds? I think that's a little low, but 9 and 10 are definitely way too high, right? They're way up here. So I think we're going to agree somewhere around 7 because I almost hit it anyway. So if my points were a little on the high side, I would be at 7. If I was the low side, I don't think I would be to 4. So there's a little bit of interpreting what we're going to do here. All right, now if the line extends a pattern in the data were extended, what would most likely be the height of a baby weighing 16 pounds? So now we're looking at the top end of this. All right, so what are I gonna do? I gotta erase a little bit of this. What do you think? So if I were to add on just like one more chart piece here, and we kind of get this thing going up here. All right, so 23 is way back in the middle. So that's way too short. So 27, 29, or 31. And we just need that baby to get to 16 pounds, which, like I said, we're just going to add this top chart along here. So I'm going to go with 27 because that would have hit the next thing. So 27 inches because I think 29, 31 is definitely way too much. 29, I think, is being a little too generous for that one extra pound. Okay. Scatter plot can be used to argue the weight of a baby is influenced by its height. Now, they definitely have something to do with each other, right? So I feel pretty good about this one, but I just want to read through the other one. So I'm going to underline it and we'll see what happens. Shorter babies weigh more than taller babies. That's definitely not true. There is no relationship. Okay, well, that's not true because we found out that there definitely is. There's a negative trend. I don't have to read anymore. This had a positive trend. So what I thought it was, A is correct. So that's how we're going to deal with those. All right, so that's our conceptual piece. The last thing we want to do is we want to take a look at if you're a U.S. production worker, we're going to find out their earnings since 1995. So this is this part here we deal with more in Algebra 2, and I'll show you that when I have you in Algebra 2. But for this year, I just know that this is kind of an SAT setup. So this would be 1995, this would be 1996, 1997, 1998. Okay, so we're going to be able to use this. We're not actually going to make this. We're going to do this in Google Sheets or in Google Doc. Actually in Google Sheets. I don't know why I have Google Doc right there. Right, and what I did for you, if you're in my class, you have this. So what you can do right over here is just go ahead and copy this stuff right here. Right, so you're going to copy it out, and then you can paste it right into a blank Google Doc. And I'm going to show you how to get all this information, make a really nice graph. So this is a skill that you're going to take over to your science class or maybe to accounting or anything else. Okay, so go ahead and copy that. And what I did is I already pasted it right back in here so you could get that information. Okay, so you can open up a generic Google Sheet here and paste this information in. And then we're going to get it all highlighted and we're going to go over and add on a chart. Okay, so pause this anytime you need to. All right, and it's going to come in here and it's going to be like, oh, this is hourly, earnings versus years. It looks great, right? Okay, we got this chart on here, but it's a line. I don't want to do a line, right? We're working on scatter plots, man. Scatter plots, that's where it's at. Look at that. You're like, hey, Mr. Toll, look at this nice scatter plot I made. And I'm like, look, buddy, that looks great. Let's see if we can't jazz it up a little bit. Okay, so all these things look great. Let's go to customize and we're going to go to series. It seems weird, but we're going to go to series and we're going to scroll down and we're going to add a trend line. I'm like, man, you really know what you're doing. And we want to keep it linear. That's good. It'd be nice if I could tell what the line of best fit was. Oh my goodness. For a label, we're going to use the equation. Look, there's the line of best fit. All right, so it's almost 1/2 x plus 11.4. Oh, okay. That means for every year since 1995, it's basically been 50 cents added on to $11.40. So that's pretty good. Now, I do want you to click on one more thing here because I want to get used to that, is show R squared. Because if I asked you for a trend here, you would tell me that it is positive, and you would have no doubt saying, you know what, this is also a strong positive. Okay. And to prove that, we're going to talk about R squared for just a second. Okay. So this is going to talk about the uh, correlation coefficient. Oh, got tongue tied for a minute there. Correlation coefficient can be anywhere between 1 to -1. Okay. Now, when it's R squared, you're never going to get the negative side of it. Okay. So R squared is always going to be the positive. So we'd have to be able to identify positive and negative on our own. But the closer to 1 I get, 0.998, is that pretty close to 1? You betcha. Okay, that means that it is a very strong correlation. Okay, even if this were going to be in the negative, right, and it said 0.998 because we had squared it to make it positive, then you'd say it's a very strong, in that case, negative. But this one is positive. Very nicely went through and made my whole chart this way. There's a couple of the things you could do in here just to make it look nice. For the points, maybe I want them to be stars. I could change out the colors. So if you had to make this look a little bit nicer for science class, just make it stand out a little bit. If you had to hand in a lab for a teacher, those is just some basic things you could do with it. Okay, so obviously with your chart, right, we could go through, we could make the whole thing centered. I mean, that looks really nice. I'm like, man, I might screenshot that and just keep that forever. I don't know. Look, bottom line is I just wanted you to understand how to do that. So setup, remember we changed it for the chart type to scatter plot. We customized it. Where did we do that through? We did that through series. And we want to go down, we want to add a trend line. What type of label do you want? You want it to use the equation, and go ahead and put that R squared on there because it's going to help you out in the future, even if you didn't understand that whole correlation coefficient. Look, I said it without having to stumble over it. All right, let's go ahead and look what questions we had down here. All right, so then draw a line that seems to best represent the data. Okay, so we found that. That was y equals 0.498x plus 11.4. Not bad for an old man, right? I remember that equation. All right, so what we could do is we'll ask follow-up questions. Okay, so it's soon going to be 2021, in case you're watching this video in the future. What? So if I go ahead and figure out how many years since 1995 is 2021, right, so that's 5 to get to 20. So we're talking about plugging in 26. So if I plug in 26 right here, then what are we going to be at? Okay, so it's going to be like 13 plus that. So we're talking about the average earnings. This is minimum wage. This is average earnings for production workers. Talking about that's about half, right? So half of 26 is 13. We'll add it on. So we're talking about 2440. Okay, so I don't know. We'd have to Google that and figure out if that's accurate, but that's definitely based on our equation, what we'd have to do. All right, let's round this out, make sure we got the right idea. So instead of selling lemonade, let's sell hot chocolate. Okay, number of cups of hot chocolate. And what else are we going to do? The temperature, right? Remember, temperature is something we cannot control. So here's our temperature, here's our numbers. Okay, so the temperature, remember I still have to say the temperature is going up, but what's going to happen as the temperature goes up to our sales? For hot chocolate, that's going to go down. I don't want no hot chocolate in the middle of summer. So notice I have a negative and a positive. So that's going to create a negative correlation. So I'm going to circle negative and deal with it that way. All right. The last one, explain whether the scatter plot of the data of the birthday. So your birthday and the number of sports you play might show positive, negative, or no relationship. I'm pretty sure this has no relationship at all, right? So I'm going to go ahead and box that up. Um, if we were in class, I'd say, all right, when's your birthday and how many sports you play? And we'd find out that there is absolutely no relationship at all. If you think there is, then we need to work on that because there won't be. I can guarantee it. All right. So that's our scatter plots. And hopefully you got your chart here. And remember, today was a lot more conceptual. And we'll add on this. Okay, make sure you can plot points. If you had any trouble with this part, um, Google something else and work on it. Otherwise, we'll work on this in class.